Yes. Good morning, dear students. In previous class, we discussed about the special cases of electric potential energy, the dipole and the dipole increased in the uniform electric field, right? And also we discussed the electrostatic shielding, correct? And Faraday case, correct? Next, the applications of electrostatic shielding. Next, we will discuss about the capacitance. What do you mean by capacitor? Capacitor. So it is also electrical components or electrical appliances. What do you mean by capacitor means? It is a system of two conductors. The system of two conductors separated by small distance. Okay, this is a system of two conductors separated by small distance. ಎರಡು plates ಇರ್ತಾವ ಅಥವಾ ಎರಡು ಇದಿರ್ತಾವ. What is circuit symbol? Circuit symbol of capacitor. ಇದು ಯಾವ ರೀತಿ indicate ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ this one indicated as like this. Okay, this is positive plate, this is negative plate. This is meant by capacitor. C means capacitor, correct? So it is a system of two conductors ಅಥವಾ metal plates ತಗೋಬಹುದು, right? Separated by small distance ತಗೋಬಹುದು, right? So this is about the circuit symbol of capacitor. Next, in capacitance of a capacitor. Capacitance of a capacitor. Capacitance of a capacitor. This is capacitor. ಹೌದಾ? ಇದನ್ನ ನಾವು ಏನು ಸ್ಟೋರ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಚಾರ್ಜಸ್. ಓಕೆ, ಇದರಲ್ಲಿ ಏನೇ ಸ್ಟೋರ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಇದ್ರಿ ಚಾರ್ಜಸ್ ಏನ್ ಇರ್ತಾವ? ರೆಸ್ಟ್ ಇರ್ತಾವ. ಹೌದಾ? ಒಂದು ಪಾಸಿಟಿವ್ ಪ್ಲೇಟ್ ಇರ್ತದೆ, ಒಂದು ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್ ಇರ್ತದೆ, ರೈಟ್? So this is capacitance of a capacitor is nothing but, so it is the storage of charges, correct? Capacitance of a capacitor, it is a ratio of charge on the capacitor to the increase its potential value, or it is the difference between the two metal plates. Howda? So capacitance of a capacitor is nothing but it is a ratio of charge given to the capacitor and the potential difference between the two plates, correct? So it is the ratio of charge. It is the ratio of charge on the capacitor, on the metal plate or capacitor, to the potential difference between two plates of capacitor. Right? This is a ratio of charge on the metal plates to the potential difference between the two plates of capacitor, like this. So capacitance of a capacitor is denoted as C. So charge divided by potential difference. So generally Q by P, or simple, it may be also used with small q also. Okay, capital Q is ಮಾಡ್ಕೊಬಹುದು ಅಥವಾ small q is P is the potential difference between the two plates, plates. Okay, this one positive plate ಇರ್ತದೆ, ಒಂದು negative plate ಇರ್ತದೆ, right? These are the potential difference between the two plates, correct? What is the SI unit of this? SI unit of capacitance of a capacitor. SI unit of a capacitance of a capacitor is farad. Ilri farad. ಇದು ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತಾರೋ F capital F. Okay, farad ಯೂಸ್ ಮಾಡ್ತಾರೋ. Farad is a very long unit. ಹೌದಾ? ಅದಕ್ಕಾಗಿ we will use the millifarad. Milli ಅಂದ್ರೆ 10⁻³ micron 10⁻⁶. ಹೌದಾ? ಆಮೇಲೆ ಪಿಕೋ ಫೆರಡ್ ಅಂದ್ರೆ 10⁻12, ನ್ಯಾನೋ ಫೆರಡ್ ಅಂದ್ರೆ 10⁻9. ಆ ಫೆರಡ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಕರೆಕ್ಟಾ? ಓಕೆ, ಜಸ್ಟ್ ಒಂದ್ಸಲ ನೋಡ್ಕೊಂಡ್ಬಿಡ್ರಿ. ಕೆಪಾಸಿಟರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಸಿಸ್ಟಮ್ ಆಫ್ ಟೂ ಕೆಪಾಸಿಟರ್ಸ್ separated by small distance. ಕರೆಕ್ಟಾ? ಸರ್ಕ್ಯೂಟ್ ಸಿಂಬಲ್ ಅದನ್ನ ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟು? ಕೆಪಾಸಿಟನ್ಸ್ ಈಕ್ವಲ್ ಟು Q by P. ಅಥವಾ ಸಿಂಪಲ್ ಡೆಫಿನಿಷನ್ ತಗೋಬಹುದು. So it is the ratio of charge to the potential difference ಅಷ್ಟು ಬರೀಬಹುದು. ಹೌದಾ? ನೆಕ್ಸ್ಟ್ Farad is a large unit. Farad is a large unit. ಅದಕ್ಕಾಗಿ ಏನು ಮಾಡ್ತೀವಿ? 1 millifarad. 1 millifarad means 1 into 10⁻³ farad. Right. 1 microfarad, that is 1 into 10⁻⁶ farad. Right. 1 nanofarad, that means 1 into 10⁻⁹ 9 farad. Again 1 picofarad, that is 1 into 10⁻12 farad. These are the smallest units of the farad of the capacitance. Next, the definition of 1 farad. Definition of 1 farad. 1 farad ಯಾವಾಗ್ತದೆ? You know this here, C equal to Q by B ಇದೆ. ಕರೆಕ್ಟಾ? So C equal to Q by B ಅಂದ್ರೆ C equal to capacitance equal to 1 farad ಯಾವಾಗ್ತದೆ? 1 coulomb of charge divided by 1 volt of potential difference is that. Correct? So capacitor is said to be 1 farad if the charge on the metal plates is 1 coulomb and the potential difference between the two plates is 1 volt. Then the capacitance is said to be 1 farad. Okay, we'll define it. Capacitance of a capacitor. Capacitance of a capacitor. Capacitance of a capacitor is said to be 1 farad. 1 farad if the charge is 1 coulomb and potential difference between the plates, between the two plates is 1 volt. Right? So if the capacitance of a capacitor is 1 farad, 1 coulomb of charge to the 1 volt of potential. Capacitance of a capacitor is said to be 1 farad if the charge is 1 coulomb and the potential difference is said to between the plates is 1 volt. 1 volt is like that. So this is said to be 1 farad. Okay, just look at once again capacitance of a capacitor and some of the units, and also the capacitance of the capacitor is 1 farad. Correct? Next we will move on to the parallel plate capacitor. What is meant by parallel plate capacitor? parallel plate capacitor. What do you mean by parallel plate capacity? You know that the parallel means two lines are parallel. Two lines are parallel. So this is nothing but the parallel plate capacitor. Okay, the two plates, metal plates, are parallel to each other. Two metal plates are parallel to each other. That is called as a parallel plate capacitor. Right? Both the areas of both the plates are same. The areas of both the plates are same. And one of the plate is positive, one of the plate is negative. Okay, parallel plate capacitor is nothing but it is a system of two parallel plate capacitors of opposite charge separated by a small distance. This small distance here what we separated, that is the distance is d. Okay, parallel plate capacitor means it is a system of two parallel plates of metals of opposite charge opposite charge separated by small distance. Separated by small distance. Okay, it is a system of two parallel plates of metals of opposite charges separated by small distance. Okay, look at once again, the two metal plates have the different charge plus and one other one is minus, separated by small distance a, and both the areas of the plates is same. Areas are same, correct? Right. So this is about the parallel plate capacitor. Capacitance of one current and also parallel plate capacitor. Next we will derive the capacitance of a parallel plate capacitor. It is a very important 5 marks derivation. Okay, so the capacitance of a parallel plate capacitor is equal to epsilon naught A divided by B. So it is a derivation. Okay, we'll do next one. So the capacitance of a parallel plate capacitor is epsilon A by D. So it is a very important derivations in this chapter, correct? So we'll derive that derivation. What is the charge? What is the Coulomb's law? What is the charge properties? These are studied in the first chapter, right? So we'll derive the 5 marks important derivation. Derive the expression for capacitance of a parallel plate capacitor. Derive the expression for capacitance of a parallel plate capacitor. Okay, so we'll have the diagram first. Diagram is so simple. I have already told you this. The areas of two plates is same. So this area is also same. This area is also same, right? So this charge is positive. This charge is negative, right? The distance between the two plates is d. Small d is the distance between the two plates, and the electric field is flows from positive to negative. Okay, the electric field is flows from positive to negative, positive and negative flow, right? So derivation of capacitance of a capacitor. So consider, you already know, consider a parallel plate capacitor. Parallel plate capacitor. Okay? A is the area of the place. Area of the place. Right? D is the distance between the plates. Right? Next, E is the electric field. P is the potential difference. Right? So A is the area of the plates, D is the distance between the two plates, next E is the electric field, and P is the potential difference between the two plates. Correct? So next we will derive the equation. Right? First of all, the capacitance of a capacitor. Already you know capacitance. Capacitance of parallel plate capacitor. Capacitor. First step. So C is equal to, you know that Q by T. Q is nothing but charge. P is the potential difference. So this is named as equation number 1. Okay. Next step, we have the relation between E and V, the electric field and the electric potential. We already derived in this chapter. So E is equal to, is nothing but E is equal to V by D. So it comes from E is equal to minus dV by dx annala adalite our equation ka badandre. So I have remembered this equation. So E equal to minus dV by dx. So we taking at the minus sign eliminated. E equal to V means potential, D means distance. So here dx is also distance. Okay. This is equation number 2. Okay. Now the electric field between the plates or wire, we already in the previous chapter now on the derivations of derive, the electric field is due to the plates or wire is equal to the sigma by 2 epsilon naught, right? So the electric field for the plates having the charges is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Okay. In the previous chapter we derived this. Okay, electric intensity or electric field is due to the wire or a plate, sigma by 2 epsilon naught. This is for one positive plate. It is one sigma by 2 epsilon naught and negative plate is sigma by 2 epsilon naught. Correct? So ಎರಡು ಕೂಡಿದ್ರೆ ಏನಾಗ್ತದೆ? E equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught means sigma by epsilon naught. Correct? So this is equation number 3. Okay, we will equate the 2 and 3 equations. Equating equations 2 and 3. Equations 2 and 3. Okay, E equal to nodri sigma by epsilon naught, that is P by D. So P equal to sigma D by epsilon naught. Okay, this is equation number 4. So this equation 4 is substituted in equation number 1. Okay, ಈ v ವ್ಯಾಲ್ಯೂ ಏನು ಮಾಡಿದ್ರೆ ಗೊತ್ತಾಯ್ತಂದ್ರೆ ಇದು e equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught ಅಂದ್ರೆ sigma by 2 epsilon naught. Okay, sigma by epsilon naught ಆಗ್ತದೆ. Next, the equation 2 and 3 is compared. Okay, equating equation 2 and 3 because the LHS term is e only. That's why sigma by epsilon naught equal to p by d. P equal to sigma d by cross multiplication sigma d by epsilon naught. This is equation number 4. This value of p is placed in equation number 1. Okay. So we have the c is equal to q by p means this one sigma d by epsilon naught. Correct. So this is epsilon naught a divided by sigma d. Correct. This epsilon naught goes to the numerator and epsilon naught a by sigma d remains. Correct. You know the surface density of charge. This is q. Okay. Right. So surface density of charge. Surface density of charge. Right. Surface density of charge sigma equal to charge by area. Right. In the previous chapter we will derive this the definition of surface density of charge sigma equal to q by a. Correct. What about q? Q is equal to sigma a. Correct. Q equal to sigma a. This q value now is equal to sigma a is substituted in this equation. Okay. So then the capacitance is nothing but epsilon naught q means sigma a divided by sigma d. Right? This sigma cancels. So the final equation is C. The capacitance of a parallel plate capacitor is epsilon naught a by d. Okay. C equal to epsilon naught sigma q means sigma a divided by sigma d. This sigma cancels. The capacitance of a parallel plate capacitor is sigma naught epsilon naught a by d. Okay. So this is the equation for capacitance of a parallel plate capacitor. Okay. ಒಂದ್ಸಲ ನೋಡ್ಕೊಡ್ರಿ ಇನ್ನೊಂದ್ಸಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. Right. Notice first it is the parallel plate capacitor of equal area of opposite signs. One positive or one negative. Right. These are descriptions. Next C equal to Q by V by the definition of capacitance. Correct. The relation between the E and V. You already derived this in your previous class. Right. E equal to V by D. And hence bರ್ತದೆ E equal to minus dV by dx ಇಂದ ಬರ್ತದೆ. Right. So electric field for the plates having the charges sigma by 2 epsilon. This is derived in first chapter. One chapter is derived by sigma by 2 epsilon plus sigma by 2 epsilon. One charge is the sigma by 2 epsilon. Another charge is the sigma by 2 epsilon. ಎರಡು ಕೂಡಿದ್ರೆ ಏನಾಗ್ತದೆ sigma by epsilon. ಕರೆಕ್ಟಾ? So equations 2 and 3 ಅನ್ನು ಕಂಪೇರ್ ಮಾಡೋಣ. ಎರಡು ಕಡೆ e ಅದ ಅದಕ್ಕಾಗಿ sigma by epsilon equal to v by d. So if v equal to sigma d by epsilon. This the value of phi is substituted in equation number 1. Okay. Next, this comes from epsilon q by sigma d. Already we know surface density of charge in the first chapter. Sigma equal to q by a. In terms of q, sigma a. This sigma a value of q is placed in here. Right. So sigma a divided by sigma d. Sigma cancels. C equal to epsilon naught a by d. Correct? Look at once again. We'll ಸ್ವಲ್ಪ ನೋಡ್ಕೊಡ್ರಿ. ನೋಡಿ next the capacitance of a parallel plate capacitor is nothing but epsilon naught A by D. Okay, epsilon naught means absolute permittivity of free space, correct, for air medium. A means area of the plates, D is the distance between the plates, correct. So here mention the factors on which capacitance of a parallel plate capacitor depends. Capacitance of a parallel plate capacitor Okay, this is very important 2 marks question. Okay, mention the factors on which capacitance of a parallel plate capacitor depends. Okay, depends. Okay, first factor the capacitance is depending on the area of the plates. Okay, it is depends on area of the plates, correct, and it depends on distance between the plates, distance d between the plates, and also it is depending on the nature of the medium, means absolute permittivity. Okay, it is also depends on the nature of medium, right. So this is the answer. Okay, this is a question. Mention the factors on which capacitance of parallel plate capacitor depends. So it depends on area, it depends on distance d, and it also depends on the nature of the medium, correct. But how it depends in area? So the capacitance is directly proportional to the area. Capacitance is directly proportional to the area, and the capacitance is inversely proportional to the distance. The capacitance is inversely proportional to the distance, and the capacitance is directly proportional to the absolute permittivity. Okay, that is the nature of medium. The C is directly proportional to the epsilon naught. C is directly proportional to the A. C is directly inversely proportional to the D. Next point is that how it is increased. ಯಾವ ರೀತಿ ನಾವು capacitance of a parallel plate capacitor ನ increase ಮಾಡಬಹುದು ಅಂತ. So ಹೆಂಗೆ increase ಮಾಡಬಹುದು? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇತ್ತಂದ್ರೆ ಇದು ಏರಿಯಾ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಇದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. If the area of the plates is increased, then the capacitance is also increased, right? If the distance is increased, then the capacitance is decreases. ಹೌದಾ? ಇಲ್ಲಿ inversely proportional ಇರೋದ್ರಿಂದ ಏನಾಗ್ತದೆ? If the distance is increases, the capacitance is decreases. If distance is decreasing, the capacitance is increasing, correct? And also if the nature of the medium, absolute permittivity of direct constant is increases, the capacitance is also increases. So if the area and epsilon naught is increases, the capacitance is also increases. If the D is increases, C decreases, right? Vice versa. Okay. So this is also very important. 2 marks question. Mention the factors of the parallel plate capacitance of parallel plate capacitor depends. Okay. So this is the derivation. This is also very important ಅದ ಸ್ವಲ್ಪ ನೋಡ್ಕೊಡ್ರಿ. So today we will conclude this chapter. ಹೌದಾ, ಇವತ್ತಿಗೆ ಇದು ಮುಗಿಸೋಣ. next class we will continue tomorrow. Okay, ಒಂದ್ಸಲ ನೋಡ್ಕೊಡ್ರಿ. ನೆಕ್ಸ್ಟ್ ಕಾಪಿ ದ ನೋಟ್ಸ್ ಎಲ್ಲ ನೋಟ್ಸ್ ಕರೆಕ್ಟ್ ಆಗಿ ಬರ್ಕೊಂಡು ಆಮೇಲೆ ವಿಡಿಯೋನ ನೋಡಿ, ಕರೆಕ್ಟಾ? ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.